Good morning, students. Today we are going to see sedimentation aided with coagulation. So, you have already seen what is sedimentation. It is simply making the impurities to settle down by reducing the velocity. The impurities settle down. Now, some impurities won't settle down. For such impurities, what has to be done, we have to see. So, the outline of today's class is definition of coagulation and flocculation, theory of coagulation, different types of coagulant used in water treatment. So, today we are going to see what is sedimentation aided with coagulation. So, many of the impurities won't settle down, which have specific gravity more than that of water, that is one. Those impurities settle down, and some impurities which are having specific gravity less than that of water won't settle down. For those, we add some chemicals so that they change their shape and size and the impurities settle down. So, the chemicals what we add to water are known as coagulants. So, this process is known as sedimentation aided with coagulation. So, basically we should know what exactly is coagulation process. So, coagulation is destabilization of colloids. Now, what are these colloids? These colloids are actually impurities which are negatively charged. So, these impurities which are negatively charged are mixed with chemicals, that is coagulants, which are positively charged. So, when this negatively charged particle comes in contact with positively charged particles, they start to mix up, they start to diffuse their layers. So, the layers which are diffused are called as diffused layer, and there is a stern layer which is formed around it. So, this stern layer will be having positively charged ions as well as negatively charged ions, which make the impurities to change their shape and size and to settle down. The chemicals which we use over here are known as coagulants. So, the main aim of coagulation, you all can see here, the coagulant is being added to the impure water. The red spots what you are seeing are impurities present in water. To that we are adding coagulants. So, these coagulants which are positively charged stick to that negatively charged impurity which is in red color and make the impurity to change its shape and size. Slowly the impurity forms a precipitate and it settles down at the bottom. So, you can see here negatively charged particles and positively charged particle forming coagulation. So, this is how impurities settle down with coagulation. So, this can be achieved in three stages. One is addition of measured quantity of chemicals to water and their thorough mixing. Second is formation of precipitate which coagulates and forms a floc. And third one is sedimentation. So, the impurity which settles down at the bottom is known as floc. So, now what exactly these coagulants and what makes these coagulants react with the impurities? There are many factors which affects coagulation. First factor is type of coagulant. Second is quantity or dosage of coagulant. Third one is characteristics of water such as pH of water, temperature, type and quantity of impurity, and third one is method of mixing. Next, what we have is flocculation. Next process, what we have is flocculation. So, now what exactly is flocculation? I said there is floc which is settling down. So, floc is nothing but when this negatively charged particles mix with positively charged coagulants, the precipitate which is mixed, when these negatively charged ions mix with positively charged particles, they contribute to form which is known as agglomeration and settle down. They change their shape, they become larger, the particle size becomes larger and they settle down. It is known as flocculation. So, coming to the next part, that is different types of coagulants. Actually, there are many types of coagulants which we use. Some I have listed over here. One is aluminium sulfate, which is commonly known as alum. The other one is chlorinated copras, ferrous sulfate and lime, and the last one is sodium aluminate. So I have put a table which you can see what is the coagulant we are using and what is its chemical name. The first one is aluminium sulfate, which we commonly call it as alum. So the chemical name for aluminate sulfate or alum is Al2SO4 thrice 18H2O. So this coagulant is the most common and universal coagulant used in waterworks. The main factor on which these coagulants work is presence of alkalinity in water. These coagulants work only if some alkalinity is present in water. If alkalinity is not present in water, it is to be introduced artificially into the water. It requires large amount of alkalinity present in water. Alum is found to be more effective in the range of pH range of 6.5 to 8.5. If the pH is less than 6.5, it is not effective. We don't find much formation of floc. That is, floc is nothing but the impurity which is settling down. For that reason, for alum to be more effective, it should be the pH of water should be in the range of 6.5 to 8.5. The dosage varies. If the pH is in the range of 6.5 and 8.5, the dose what we are applying, that is, this alum is dissolved in certain amount of water and it is applied to impure water. So the dose of alum varies between 10 to 30 mg per liter of water. Apart from reducing turbidity, alum also reduces taste and odor. And the floc which is formed by making use of alum is 2AlOH thrice, which is nothing but aluminium hydroxide. So the major thing what you people have to remember when we study about coagulants is what is the coagulant that we are adding to water. The coagulant what we are adding to water in case of alum is Al2SO4 thrice 18H2O. This is the chemical name for alum. So when it is added to water, it reacts and forms aluminium hydroxide. So this aluminium hydroxide is in the form of precipitate which settles down. The next we have is chlorinated copras. So this chlorinated copras is nothing but hydrated ferrous sulfate, which is traditionally referred to as copras. Okay, so hydrated ferrous sulfate. This is unstable. It easily gets oxidized into ferric sulfate and also to ferric chloride. So it is unstable and it is easily getting oxidized to ferric sulfate and ferric chloride. So this ferric sulfate and ferric chloride are used to form precipitate separately. So this ferric sulfate when used, it is used in the pH range of 4 to 7 or above 9. So when the pH is in the range of 4 to 7 or above 9, this ferric sulfate reacts with water to form floc. Same way, ferric chloride also is effective in the range of 3.5 to 6.5 or above pH 8.5, which you can see in the table. Okay, so when these two things are used from chlorinated copras, they form a common floc which is known as ferric hydroxide. The common floc which is formed is ferric hydroxide which settles down. So chlorinated copras is second coagulant what we use to remove the impurities present in water. First, it is unoxidized. It easily gets oxidized into ferric sulfate and ferric chloride, which is more effective in the range of 4 to 7 and above 9. Ferric chloride is more effective in the range of 3.5 to 6.5 and above 8.5. So the common floc formed is ferric hydroxide, which is nothing but FeOH thrice, which settles down at the bottom. Then the next coagulant what we make use is ferrous sulfate and lime. many a times when this ferrous sulfate is added to water, it will be having less alkalinity present in the water. So when we add ferrous sulfate to water, the process of formation of floc will be delayed. For that reason, we also add lime to it so that the process gets accelerated at a faster rate. So the chemical formula is FeSO4 7H2O. This ferrous sulfate is more effective in the range of 8.5. The floc again formed over here is FeOH thrice. The next coagulant what we make use of is sodium aluminate. So this sodium aluminate is given by chemical name as Na2Al2O4. It is effective in the range of 6 to 8.5. The floc formed helps us to remove temporary and permanent hardness from water, which is nothing but in this case we will be having CaAl2O4, which is the floc formed. The most commonly used coagulants for different sources of water are alum and ferric sulfate. So you can see the reactions given over there. So this alum reacts with lime to form aluminium hydroxide, which is nothing but the floc which is settling down. CaSO4 is the hardness caused to water which can be removed later. Same way we have ferric sulfate which is formed, which reacts with alkalinity present in water, and the floc formed is ferric hydroxide. Apart from that, we will be having permanent hardness which is introduced to water which can be removed from water. So these are the two main things which we use, that is alum and ferric sulfate. The reason behind using alum and ferric sulfate in wide range is it's having many advantages. Alum especially removes turbidity. Apart from turbidity, also removes taste and odor. It also has advantages like it very easily dissolves in water and also doesn't leave back any reddish brown stains to the floor or equipment where it is used. The main disadvantage is it is effective only in the prescribed pH range, and the flocculation may not be possible when alum in some form of in some other water it may be not effective. The other advantages of ferrous sulfate: ferric hydroxide is formed at low pH values so that coagulation is possible with ferric sulfate at pH value as low as 4. Ferric hydroxide is insoluble and can be easily removed. The floc formed with ferric coagulants is heavier than alum floc. The ferric hydroxide floc does not redissolve at any other high pH values, and also ferric coagulant may be used in color removal at high pH values required for the removal of iron and manganese and in softening of water. So by this we conclude with sedimentation aided with coagulation. In the next class I will be starting with filtration. Thank you.